Today we are going to start about Unix architecture. So in these sessions we are going to learn about components of Unix architecture. The first is hardware, second is kernel, then shell, the command line and utilities that are present in Unix application. Then we're going to see properties of Unix operating system, or the types of operating system we have, and yes, of course, the general diagram of Unix architecture to understand its the components. Okay, so let's start with hardware. So it's hardware is so if you see, yeah, so what is hardware? So yeah, in general the hardware is a part of computer which includes the clocks, timer, device, parts, etc. So like it's a tangible components where you can actually not touch and going to see with your eyes, and yes, is a kind of a hardware. So what it contains, like it contains large number of hard drives. Then the hard drives can be like HDD or SSD. Okay, then we'll see like it control use of physical system resources such as memory. It actually holds the memory, so memory like okay, the process manager, then disk space, basically devices, drivers are the components of the hardware. The kernel controls the hardware of the computer and decides the core part of architecture. Okay, so we'll see next kernel. And yes, of course, you can expand devices, you can expand drivers, you can add storage space at any moment. You can expand the memory at any moment. Okay, so yes, this is how the hardware component is all about. Then the next topic is about the kernel. So yes, so what is kernel? So kernel is the heart of the operating system. Okay, what are the functions of kernel? It's manage memory, it's control the access to the computer, maintain the file system. Like we can say, like we will say like df-h when you issue a command, that you can see the then you can see the file system present on the that particular OS. Okay, then of course it's handled the interrupts, it handles the errors. It also helped input and output devices. And okay, then kernel allocates memory to the users. Okay, what are the users, what are the application based functions, what are the kernel based functions. Okay, we'll see that in the next topic. Okay, so it allocate the resources. When we will see like in kernel types, that you will come, you will understand how does it happen. Yes, so kernel is the most important part of architecture, as we have seen in earlier slide. So yes, so what is next? Of course, it's facilities. It's provide the facility where you can interact between the hardware and software components. Okay, so this is kind of a kind of interface between hardware and software. Okay, yes, so though whenever the server start, okay, or whenever the OS start, so this is the first program which will load into the memory. Okay, so it's handle a lot of things like the startup, memory manager, peripheral devices, input output request, software translating the data into the processing unit, into the processing instructions for the CPU. Okay, so all these functions are handled by the kernel itself. So the next topic is that we will see what types of kernels. Okay, so there are types of kernels in the market. We'll see, yes, what is monolithic. Okay, then we'll see microkernels, monolithic kernels, microkernels. Then we have hybrid kernels, and then we have okay, nano kernels, exokernels, and multi kernels. Okay, so these are the types of kernels. So what is monolithic kernels? It's run entirely in single address space. Okay, and mainly for speed purpose. So whenever there is a speed kind of a we require more performance, we should be using the monolithic kernel. Okay, Linux kernel is a monolithic. Okay, so of course we'll see how this happen. Okay, microkernels run most but not all their services in the user space. Okay, I think so. Prior to start off the types of kernel, we must understand how this happens. Okay, so usually kernel is loaded into a separate area of a memory. Okay, whenever the server start. Okay, it loads the all startup parameter all startup components into it. Okay, so usually while doing this, it allocate a memory based on the application user space. Okay, and for the memory space for the functioning of the OS itself. Okay, so based on these two logic, it allocate the space to it. Okay, like separation between the user data and kernel data from interfering with each other. Okay, why it is done? So kernel space and user space. So kernel space is basically for the performing the tasks such as running processes, managing the hardware devices such as hard disk, handling the interrupts, and the protects from the kernel space. Okay, so if no kernel is doing this, so it will again no going to help that the user space specific process no not going to interact with the kernel space. So of course you will have a good performance. Okay, user space like application programs such as browsers, word processors, and audio video players are separate from the memory. Okay, so of course these are the user specific functions where these are going to be separate from the kernel space. Okay, yes, of course by doing this we can prevent the instability and slowness. Okay, so yes, kernel performance will be increases. So preventing malfunctioning and applications from affecting other applications and crashing the entire operating system. Yes, of course the same one is, and it's elaborated in a different way. Okay, so now we got to know how the kernel space is going to be uh, allocated for the kernel specific process and the user specific process. So based on the same logic, the types of kernels has been designed. So first is monolithic, where the entire run in single address space, so everything run in one space. So it's mainly for speed. Linux is example of monolithic kernels. Okay, so the microkernels run most but not all their services in user space. Like of course they use microkernels where the kernel space is different than the user space. So it provides the resilience to cover quickly from the difficulties. Okay, so if you have a microkernels in place, we can easily be able to recover from the difficulties. Like it's more into resilience. Then modularity, the quality of consisting of a separate parts that when combined form other complete one. Okay, so example is microkernel is Minix tree. Okay, the next type of kernel we have hybrid. Okay, or modular or kernels we can say. So most commercial operating systems such as Microsoft Windows NT 3.1, NT 3.5, NT 3.51, then NT 4.0, 2000, XP, Vista 7, 8, 8.1 and 10 are the examples of hybrid modular kernels. So Mac OS is a hybrid kernels. Okay, so MacBook is basically into called as an hybrid kernels. So it include some additional codes in the kernel space to increase the performance. Okay, so we can, like I'm using the MacBook Air. Okay, so of course from last 10 years I was using the Windows based system, but now I started using the this MacBook Air. So I can see a lot of in terms of performance wise, yes, of course it's very best in the market. Then the next one is this nano kernels, visual service like virtual service which are interrupt controller, timer devices, drivers to make kernel memory requirements even smaller than the traditional microkernels. Okay, so these are the types like exokernels and multi-kernels. So we are not going to deep into those particular kernels. Okay, so this is how the kernel is. The next point is like, okay, we have already seen. Okay, now the third point we have, yes, shell. Okay, so this is very important shell. Okay, when you type any command in Unix terminal, like if you open the any Unix terminal, so you can connect to operating system with the help of putty. Okay, you can install Unix, Mac OS, or any of the Unix flavor like Linux or Ubuntu. Okay, Fedora into your VM, and then you can have a terminal where you can actually going to interact with the OS. So it's a terminal. Okay, it's kind of a terminal where you are going to type a command. Like there are various lots of commands in the OS specific. So if you are L1 L0 activity, so few command you need to be very much aware, familiar. So you can only be going to be upskill in those particular area by just doing practice. Okay, so we'll see those command into next session. Okay, so yes, what are the utilities we have? Okay, what are the types of shell we have? The C shell, bound shell, and K shell. Okay, so basically, how you can see with what kind of shell we have, you can simply pass echo bash, echo dollar bash, or a bash, I would say. Okay, you can see what kind of bash it's running. Okay, and yes, we'll see the commands in more into broader area. Okay, so in next session we are going to learn about commands and utilities we have. What are the Unix applications, what are the properties of operating system, types of operating system in OS, and diagram. Okay, so we can see the diagram in this session. Yes, so this is how the Unix architecture looks like. So the outer peripheral is like application programs. Okay, this center one is hardware. On the top of that we have a kernel layer, and on the top of that we have a shell programs. Okay, these are the commands like vi, these are the editor, this is the utility. Then we have a environment variable which is a no kind of a command, more, bash, these are the shell programs. Okay, so these are the on the top of kernels. Then we have the application programs, what like in which are there in Unix architecture, like some mailx function, sftp, ftp, dbms. Then we have a was servers, application servers. Okay, many more functions you can install on the Unix. Okay, so these are the outer side. Okay, so whenever the you can see your kernel and hardware, like how they are closely bind together. Kernel is the heart of the OS or the Unix architecture, where it's going to allocate the memory for user specific process, and of course for the application process. Okay, so these are the application programs. The list can be we have a lot of application programs, but yes, for to easy understand, like mailx is a function, sftp from or ftp, file transfer protocol, I would say. And then we have a dbms, like lots of dbms are database applications are installed on the Unix. Maybe in Solaris or Linux is used in the market. Okay, like Oracle, Sybase, when we have Mongo, Postgres, all the database softwares. Okay, are installed on these OS. Okay, thank you. If you have any questions, you can ask, you can add into a comment, so possibly we'll cover those as well. Okay, thank you.